Welcome back to digital class, and this is a discussion for booklet number 10, solid figures and nets. And now we are focusing on our attention on solid figures. So we can look at section A, introduction of solid figures. Now, the first thing we need to understand is what is the meaning of solid figures. And solid figures in simple, it is actually the three-dimensional, or what we call it as 3D figures. Okay, and to know what is actually a 3D figures in simple, it actually take up spaces, and it has length L, width W, and it also have height. And these things actually give us something called volume. Okay, give us something called volume. And with this, we can calculate the volume of an object, calculate the volume of a liquid. Yeah. Okay. And there are also some examples of the solid figures. And of course, we commonly know this as a cube, whereas all of these have the same length, the width, and height. Okay. And we also have something called cuboid. We have something called cone. We have something called a cylinder. And you notice that these three things are actually something called pyramid. Okay, pyramid. And this is also pyramid. However, to be specified, you will notice that the base here is actually three sides. The shapes here is actually four sides. The shapes here actually have five sides. And actually, we have a specific name for all these three different pyramids. So this is something we call it as a triangular pyramid. And with a rectangle shape, we call this as a rectangular pyramid. And this is actually a five side shapes. It is actually called pentagon. So we can have pentagonal pyramid. Pentagonal pyramid. Okay. And this is something very interesting to know. And when you talk about solid figures, and it usually also have some parts of it that you need to know. The first thing is called the face. Example, you can see here. Let me just quickly highlight. And this is basically the face of the cube. Of course, like all the shapes actually have a face. Now, the next thing you need to know is something we call it as edge. Okay, now, example, this is the line. As you can see, this line is actually the edge. Okay, this line is edge. And the next thing you know is something we call it as vertex. Okay, vertex. And basically is the sharp point of this. Okay, yeah. And for example, cube, we actually have 8 vertexes. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. So after we know all of these things, then is something important for know that among all these solid figures that we can see, as you can see, 1, 2, 3, 4, 5, 6, 7, actually only 2 are actually considered as something called prism. Okay. Now, actually it's only cube and cuboid are actually considered as prism. So, and a very important thing is now you need to know is what is the meaning of prism. Okay. Now, I actually listed out 3 characteristics or 3 checklists. Means that you must make sure that this object have all these 3 things so that it can be considered as a prism. If it does not meet one of these, it is not considered as prism. The first thing here says that at least one pair of opposite ends have the same face and have the same size. Okay. The next thing, all edges are actually straight. The next thing, same cross-sectional all along its length. Now, this is a quick example. Just now we say that cube is actually prism. Now, is it really a prism? Let me try to draw here. Okay, this is a cube. Now, I say at least one pair of opposite ends. So how many pair of opposite ends do you actually have this cube have? Actually more, right? This and this side are the same. The one on top, so the same, on the side also the same. Okay, at least one, right? We have at least one. Edges are all straight. So we can see all the line here, straight, 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 straight. And same cross-sectional all along its length. Means that here is straight, straight, its length. Okay, so means that cube is also correct. Cuboid, example, I'm drawing like this. Now this is cuboid. And cuboid also is considered as prism. Why? Because at least one pair of parallel opposite ends. So this is also the same as here. Of course, the up top, the bottom, the face are also the same. Edges are all straight and same cross-sectional all along its length. Okay. However, you might be questioning, teacher, how about cylinder? Now, cylinder also the same, right? Okay, I'm not drawing that nice. At least one pair of opposite end. Correct, right? There's one pair here and here. Edges are straight. Edges are straight. Same cross-sectional all along its length. Yeah, see, it's all the same. Again, here say that the edges are straight. However, this edge are actually not considered as straight. So this is not considered as a prism. This is not considered as a prism. Okay. Now, a quick one here say that identify its if the solid figures are prism. If no, explain. Now the first one. Do you think the first one is actually a prism? Now let's check. At least one pair of opposite ends have the same face and same size. If you look carefully, yeah, this side and this side are the same, opposite end, right? All edges are straight. Yeah, all edges are straight and same cross-sectional all along, isn't it? Yeah. This actually basically means that if I want to cut here, I cut it will still be the same thing as the one on top and the one at the bottom. Okay, so this is yes. How about this one? This one, if you want to try to look at it, it's actually also the same here and the one here. Correct, right? If I were to actually try to cut it out, cut along its length, it also will be like this. Okay, and this is also the same. So this is also yes. However, if the last one isn't the same, now look at the last one. If you want to say opposite one pay, same face, this is triangle, this is also triangle, right? But can I say is it the same? No, because the question says what? I mean the requirement says same size. Edges are all straight, okay, but same cross-sectional all along its length. This also doesn't meet. Why? Because if I cut in the middle, the triangle is small, big, and the biggest. So this is no. Why? Because it doesn't have the same size at the opposite end, and it's not the same cross-sectional sectional along or along its length. Okay, basically means that the first one and the third one, it does not meet the requirement. Okay, and basically this is the notes that you need to know about the solid figures. And with this concept, I hope you can go and try it out, find out some of the questions that will be seen there soon. Okay, and thank you so much, and we'll see you. Bye bye.